In this lesson, we're going to discuss two types of probability, theoretical and experimental. But a little intro to probability, that's something to just remember at all times. Is probability is nothing more than fraction of the likely outcomes divided by or over the total number of outcomes. So when we think probability, your best guess is to figure out what is the total amount of outcomes and how many times is it likely to happen. How many times is it favorable to happen? So your favorable outcomes, we can say not necessarily likely. That might have been a bad word. Let's go with favorable outcomes divided by the total number of outcomes. So with probabilities, they can range from 0 to 1 in fractions. So it's all fractions. Or we can use them as percentages, 0% to 100%, where something that's 0% probability is impossible to happen, will not happen. Something with 100% probability is certain to happen. It will happen 100% of the time. Most probabilities fall somewhere in the middle. These two cases are special cases. So in my bucket, I have 4 white, 3 red, and 1 blue marble. What is the probability of pulling out a red marble? So the first one, you're going to see this P standing for probability, red in the middle, meaning what's the probability of pulling out a red marble? Well, it's going to be a fraction. The favorable outcomes. How many red marbles are in the bucket? Well, there are 3 red marbles in the bucket. Well, how many marbles in the bucket total? 4 plus 3 plus 1 is 8. So the probability of pulling a red one would be 3 out of 8. Probability of pulling a white one, well, there are 4 favorable, 4 white ones out of 8, which means you have a 1 out of 2 chance of pulling a white one. Probability of pulling not blue. Well, how many marbles are not blue? Well, there are 7 that are not blue. So you have a 7 out of 8 chance of pulling a marble that's not going to be blue. Probability of pulling red or blue. Well, there are 3 red. There is 1 blue. So there's 4 red or blue marbles out of 8 total, which means you have a 50-50 chance, a 1 out of 2 chance of pulling a marble that is red or blue. Probability of pulling a purple one, 0. This is that special case. There are no purple marbles in the bag, so it is impossible to pull a purple one. And the probability of pulling a red, white, or blue one, that's all that exists. It would be 1. It's 100%. Certain to happen. Now, there is something called complementary events in probability. And complementary with an I is giving somebody a compliment. It is not a part of probability. But a complementary with an E does happen in probability. So what is the probability of rolling a 4 on a number cube? Well, there's 1 4 on a number cube. There's 6 sides on a number cube. 1 out of 6. What is the probability of not rolling a 4 on a number cube? Well, there are 5 options that are not 4. So that'd be 5 out of 6. So look at this. If we take 1 out of 6 and we add it with 5 over 6, we get 6 over 6, which is 1. So complementary events are probabilities that add to 1. And they typically have to deal with the same scenario. So it's more or less, an event and its complement represent the complete set of possible outcomes. Total set of possible outcomes. The probability that that event will happen, plus the probability that it will not happen is always going to equal 1. And if we can't find the probability of it not happening, we can always just take 1 minus the probability of the event to come up with that case. So for instance, let's say we have, what's the probability of drawing an ace from a deck of cards? Well, there are 4 aces in a deck of cards. There are 52 cards. So we have a 4 out of 52 chance. If I reduce that, that reduces to a 1 in 13 chance of drawing a ace. So I'll say probability of drawing an ace. So probability of not drawing an ace, well, that would leave us with 48 cards that are not an ace out of 52. If I were to add these together, you'll notice that I would get 1. But I know that I can reduce 48 over 52. And when I do that, I would get, let's see here, going to divide those both by, well, we could divide them both by 4 and get 12 over 13. Again, 1 over 13 plus 12 over 13 gives us that 1. So there's an example of an event that is complementary. 2 types of probability we want to focus on here. We have theoretical probability. This is where we use the math. So we just use the math to figure out some probabilities there. It tells what's supposed to happen in theory. So for example, what's the theoretical probability of flipping a coin and getting a tails? Well, there's 1 tails, there's 1 heads, 2 total outcomes. 1 tail means 1 favorable outcome. It's 1 out of 2. Theoretically, that's what we have. We have 50-50 chance of flipping a coin and getting a tails. Experimental probability is probability based on data collected. Like you perform an experiment, it doesn't always match the theoretical, but if you perform the experiment many times, sometimes you got to do it billions, you should get very close or even achieve the theoretical probability. Sometimes your experiment doesn't work out where it's exactly the same as the theoretical, but if you do it over and over and over again, you will be very, very close. So, flipping a coin, getting the tails, we said 1 out of 2. We already did that one. Experimental, let's say you pulled out a coin and you started flipping it. And let's say you flipped it 10 times. And let's say 3 of those times it landed on heads. And 7 of those times it landed on tails. So here, experimental probability would be 7 out of 10. Doesn't exactly match. Or maybe you did your own little experiment and it only landed on tails 3 times. Well, then it would be 3 out of 10. Experimental probability, you have an actual trial where you perform some sort of experiment. What is the theoretical probability of rolling a number cube and getting a 5? There's 1 5 on a number cube. There are 6 sides. So probability of rolling it and getting a 5 is a 1 in 6 chance. And again, we could perform this experiment. Let's say you rolled it 10 times and you got, I don't know, you had 10 rolls. Let's say you had 3 5s. Well, the probability of rolling a 5 in those 10 tries would be 3 out of 10. Standard deck of playing cards. Remember, standard deck of playing cards has 52. If 1 card is selected, what's the probability of that card being a heart? Remember, there are 4 suits. If they're divvied up equally, there's 13 cards in each suit, so it would be 13 out of 52, which reduces to 1 out of 4. probability of card being a 4, well, there are 4 4s in a deck out of 52, which would reduce to a 1 in 13 chance. If 2 dice are rolled, what is the probability that the sum of the 2 dice is equal to 7? We need to come up with all the possible options of rolling 2 die to figure this out. This is a very, very common option. So remember yesterday from our fundamental counting principle, or whenever you did that, we have 6 possible options on the first die. We have 6 possible options on the second die. If we multiply those together, we get 36. There are 36 total outcomes when we roll 2 die. Here's all of them. We could get 1, 1, roll a 1 and a 2, a 1 and a 3, a 1 and a 4, a 1 and a 5, a 1 and a 6. Or you could roll two and a 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. We're wondering when the sum of the 2 dice is going to be equal to 7. Well, let's think about this. I'll just have to keep going. We got 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, and 3, 6. We got 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6. So I think you see where I'm going with this. And then the last row, we got 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, and 6, 6. Now, a sum of 7. Look at this diagonal row. All of these options add up to 7. There are 1, 2, 3, 4, 5, 6. So we have a 6 out of 36 chance, which reduces to 1 out of 6. Keep this if 2 dice are rolled in your mind, in your brain, throughout this whole probability unit. There are 36 choices when 2 dice are rolled. If you need to write all the options, have the picture ready, do so. It will help you in determining these probabilities. Table shows the results of choosing one card from a deck of cards, recording the suit, and then replacing the card. Experimental probability of choosing a diamond would be 9. Lost my ability to write here. Would be 9. Oops. Oh, it all came back to me. Something's goofy happening. Okay, we got 9 out of, there's 5 plus 9 gives us 15, 21. This would be 9 out of 26 if I had that right. Finding the experimental probability of choosing a card that is not a club. Well, if there's 26, that would be 19 out of 26. So there's part A, there's part B.